Welcome to the channel Physics Made Easy. In the topic of collision, today we will discuss perfectly inelastic collision. We have discussed in the previous videos elastic collision in one dimension and two dimensions. We have seen that energy transfer is maximum when both the objects in the elastic collisions are of the same mass. Today we will see what is inelastic collision. What are its characteristics? First of all, inelastic collision is said to be such type of collision in which when the two colliding objects stick together and then they move with some common velocity after collision. So, what is perfectly inelastic collision? First thing, that if one object mass m1 is moving with the velocity u1 initial velocity and it strikes the other object moving with the velocity u2 and its mass is m2, its mass is m1. What happens after collision? They stick together and then they move with the common velocity v. What is here? This mass m1 plus m2. Then this is called perfectly inelastic collision. What is second thing to be learned? That as common in all collisions, what is the quantity which remains conserved? Momentum. So you will write here conservation of momentum, that is momentum remains conserved. What will you write? The expression m1 u1 initial momentum plus m2 u2 will be m1 plus m2 into v, final momentum. From this expression you can find out what will be the common velocity, that will be m1 u1 plus m2 u2 upon m1 plus m2. What is the third one? As we have seen that in the elastic collisions, kinetic energy before and after collision was conserved, but not during the collision. Why? Because elastic collision, deformation, when the two objects during the collision they collide with each other, deformation was produced. Since the collision was elastic, then when the deforming forces were removed or after some time they regained, the objects regained their original position. So kinetic energy was also recovered. What happens here? They remain stick together. Whatever is the kinetic energy transformed into the other forms, it remains. So what is the point? Third point, that kinetic energy initially before collision is more than after the collision. Why? Because the objects which are colliding in the inelastic collision, they are stick together, they are not getting their original shape back. Therefore kinetic energy is also not recovered. That is why we say that kinetic energy initial is greater than kinetic energy final. All these three characteristics are true for 100% perfectly inelastic collision. Normally all the collisions, some of the energy is always lost. So no collision is perfectly elastic or perfectly inelastic. But here we are discussing perfectly inelastic collisions, then all these 3 points, these 3 characteristics hold 100%. What happens that if you have to prove kinetic energy initial is greater than kinetic energy final, then you will show that the difference of energy is a positive quantity. How will you show? I will tell you. Now before that, coefficient of restitution for inelastic collision, which is ideal, is 0. This also we have read that coefficient of restitution is given by velocity of separation upon velocity of approach. We have seen in the previous video. What is here? This velocity of separation, this is v2 minus v1 upon u1 minus u2. Here, since no v1, v2, after collision both the objects are moving with the same common velocity. So, v2 and v1 are same, this is 0, that is why E equal to 0. So, since v1 and v2 are same, therefore E equal to 0. So, it is asked that why can you say that in perfectly inelastic collisions the coefficient of restitution is 0. How can you say in this way? Now, these are the characteristics of perfectly inelastic collision. Now, we will see the questions based on the inelastic collision. First question is asked in the exam DCE 2009. This question says that a bullet strikes the wooden target and after collision it remains stick with it. It is embedded in it. Then which option will be correct? First is given momentum is conserved, second is given kinetic energy is conserved, third is given both P and K are conserved, and fourth option is given P and K are not conserved. Simple. We have discussed the properties. Momentum is conserved in all collisions. Kinetic energy is also conserved in elastic, but here since the bullet is embedded in the target after the collision. So, which type of collision is this? Inelastic. So, both are not conserved, only the momentum is conserved. So, first part will be the correct answer. Now, let us see the question. Find the fractional change in kinetic energy when an object of mass m1 moving with velocity u collides with other object of mass m2 at rest, and after collision both move with the common velocity v. This is the inelastic collision. Then this is the first object moving with the velocity u m1 and it strikes with m2 which is at rest. After collision both m1 and m2 stick together and move with the common velocity v. How will you find the velocity v in terms of m1 m2? By the conservation of momentum. Momentum conservation says that m1 u1 equal to, this momentum will be 0, this will be mass m1 plus m2, so will be equal to m1 plus m2 into v. Therefore, v will be equal to m1 u1 upon m1 plus m2. Now, what will be the initial kinetic energy? You know what is the meaning of fractional change? Fractional change means change in kinetic energy upon initial kinetic energy. Learn the meaning of this word. So, first you will find what will be the change in kinetic energy, that is K initial minus K final. What will be K initial? Half m1 u1 square, this is at rest, minus half, this will be m1 plus m2 and v square. This is, now you can write here this half as common, this is m1 u1 square minus what is this m1 plus m2, and you put the value of v square, then v square is m1 square u1 square upon m1 plus m2 whole square. In this square this one will be cancelled, take LCM, then what will you get here? If you m1 u1 square here, m1 u1 square here, it is common, what will you get here? This is half m1 u1 square, you can write here this is 1 minus m1 upon m1 plus m2. That is, finally you can write this is half m1 u1 square, m1 plus m2 minus m1, so it will be m2 upon m1 plus m2. This m1 plus m2 minus m1, so m2 will be left here. This is the change in kinetic energy. Look what is asked, fractional change. Fractional change means therefore delta k upon ki, change in kinetic energy upon initial kinetic energy. What is initial kinetic energy? Only this one, this is ki. What is change in kinetic energy? This total. Look what is left here, this will be only m2 upon m1 plus m2. How? This half m1 u square, u1 square upon this half m1 u1 square will be cancelled, only m2 upon m1 plus m2 is left. You can also say that if somebody asks that prove that kinetic energy initial is greater than kinetic energy final. From this expression you can say that this delta k is a positive term. What is delta k? Kinetic energy initial minus final. So since difference is positive, it means initial kinetic energy is greater than the final. In this way you have to solve the question. Another question which is asked in JEE exam 2015 in the year. This question says that a ball of mass m moving with the speed 2v along x-axis is hit by another ball of mass 2m moving along y-axis with the speed v. If the collision is perfectly inelastic, then find the percentage loss in kinetic energy. Since the collision is inelastic, how will you solve? Look, we have seen that in the inelastic collision both of the balls stick together, they move with the combined velocity. Let that combined velocity is v dash. Then along x-axis, what is the momentum? M into 2v. Along y-axis, momentum is a vector quantity. What is the momentum? 2m into v. And the resultant momentum of these two, this will be, both of will be stick, then with the 2m and m, both of will stick, the mass will become 3m and the velocity is supposed v dash. Momentum conservation is applied here. Look in the vector form. What will be this vector? Equal to square of this vector will be equal to square of vector along x-axis and along y-axis. What can you write here? This 3m v dash whole square will be equal to m into 2v whole square plus 2m into v whole square. That is 9m square v dash square equal to 4v square m square plus this is 2m into v. This is 4m square v square. Look here, this m square is cancelled, this 8v square and this is 9m v dash square. So what will you get? This v dash square will be equal to 8v square upon 9. What will be the kinetic energy, change in kinetic energy? How will you find change in kinetic energy? That is k initial minus k final. Initial kinetic energy, what will you write here? This is half m into 2v whole square plus half into 2m into v square minus what is final kinetic energy? What will you write? Half into 3m, both the masses are stuck together, and v dash square. What is v dash square? 8 by 9 v square. So you will solve here. This is again, this is 4v square upon 2, so this will be 2m v square plus here this is 2 will be cancelled, mv square minus this is 3 by 2 m into what is v dash square, 8 by 9 v square. So what is here, this is 3 mv square minus this 3 ja 9, 8 2 4 ja, so this will be 3 mv square minus 4 by 3 v square m. So what is here, 9 minus 4, this is 5 by 3 mv square. Percentage change, percentage loss in kinetic energy. How will you find? Change in kinetic energy upon initial kinetic energy into 100. What is change in kinetic energy? This is 5 by 3 mv square. What is initial kinetic energy? This total, what is this total? 3 mv square into 100. So this mv square and this 3, 5 by 3, this is 5 by 9. What will you get here? This will be around, this is 500 by 9%. So in this way you have to solve questions based on the perfectly inelastic collision. I hope you must have enjoyed it. Thank you.